Let me enable the attendance. Attendance. Okay, the attendance is enabled now, guys.
Okay, I will talk in English.
In fact, this is what will happen in all the labs. You may or may not. You will learn something from.
Live for 5 minutes.
Sure. I did not even think. I'm not sure if I.
I'm going to
No.
have this norm.
I don't know whether. Okay, how many people we have?
Amar, I'm just
46
trying to
only.
make you the
Okay.
host.
Do you guys have a class or
Damn
anything
thing,
right now? I mean,
could
just
never
before
really
this particular lecture? Oh, is it? The voice is still breaking? What can we do with WebEx? Let me check what is my internet speed. So at least my speed seems fine. These days my broadband is working very nice, We should say, we say nazar nahi lagni chahiye, but at least it is doing fine these days.
Jai Jio.
Yeah, Pranav, actually we'll see, what is the actual number, if it is below 100, we can surely go to, yeah, good morning everyone. If it is below 100, then we can surely move there. I personally prefer meet anytime. It's just that it's this 100 participants problem that that we cannot resolve. So we'll see how many participants. Already we have 62. I have only received attendance for 18 till now, so please mark your attendance.
I'll have to go to participants. Host.
So thank you guys. Thank you the TAs. Prepare yourself. Someone had used the term. So I know I will be. Uh,
Hello guys.
Hello,
So
sir.
Hi, sir.
Hello, sir.
हेलो सर
यार सर मत बोलो भैया बोलो कोई बात नहीं.
हाँ भैया.
हाँ.
So, any volunteers for today? Or shall I start picking up people? It's
So
only 16. Yeah, Pranav, yeah, you are one. Any more? So shall I
A
start
couple
with
of us had volunteered yesterday. I don't know.
Yeah, so any more people who would like to volunteer? Actually, I think the previous class has not yet finished, is it?
So I don't think we had any lectures before this.
Someone said,
Sir,
someone said that you had a lecture. Okay. Because I mean, the participants that I have currently are 64 only. That is rather low. Okay, we'll probably wait for a couple more minutes.
Sir, that is maybe because we have a morning class today.
That is what. So I thought there is probably class going on, and they'll only be able to come once the class is over.
So we had fours, but that was up to 9.
Up to 9. Okay. Yeah, then they should be here.
Yeah.
And what about attendance? 59 in the attendance till now. Okay, one more minute and then we'll start. Oh, you had
Sir,
sports today.
sir,
Okay.
sir, I had a doubt.
Yeah, sure. Go ahead.
Sir, how can we update something that is embedded in the motherboard like BIOS?
Okay, so what happens is something like this. Whatever you call as ROM, it is, I mean, it is not really exactly a ROM thing, right? So basically, the point that it says read only memory, it means that the regular circuitry that you use to read or write at a particular memory location, that cannot be used to write that particular chip. Okay, but there is something known as flashing. Okay, so basically there is one process with which you can actually erase and rewrite stuff on a ROM. Okay, when you start studying more about ROM in probably computer organization, so there are erasable ROMs and then erasable programmable ROMs. So there are different types of ROMs also. So what happens is in this particular case, right? So let us say you want to update your BIOS, a small program. So that same program that was running on your chip, there is, let us say, the hardware manufacturer. First of all, BIOS updates are very rare. Let me be very frank. It is quite possible that you used a laptop for maybe 10 years and there was no BIOS update in that period. Usually BIOS updates come only when there is a critical security bug that has been found in the hardware. Only then do these hardware manufacturers release a BIOS update. So what happens is there is a circuit within your um within your motherboard which is capable of actually writing the BIOS. It is not really something that is similar to how you read or write a particular memory. So what happens is you have to download that so-called BIOS update. It has to be stored at some location. Frankly, even I never really looked into where do they store it. Okay, so I'm not sure CMOS battery has so much space or not. Maybe it has. I've never really looked into where do they store the program before flashing. So that I'm not sure. It is possible that there is some mechanism to do it in the motherboard. So there might be some more place where they can store it. The idea is that there is a whole concept of flashing where you can rewrite a particular ROM chip with a new version. But the problem is this flashing, it actually degrades your hardware also. So it means that it should not be done very often. Okay, it is done, um, very very rarely. Three updates. Yeah, so the issue really is that it's about criticality, right? You usually do not change BIOS. it's only about criticality. How critical is something that that has come up. And for example, I used to have a PC. Okay, when I was in class 11th and 12th, I used to have a PC, and I used that PC for almost 10 years. And towards, I think, the end of my usage, there was a BIOS update for it, right? So in about 10 years, there was just one BIOS update. So usually BIOS updates are extremely rare, because that has to be released by your hardware manufacturer. So for example, BIOS update would come from companies like Intel or AMD. It won't come from Microsoft or Apple. It comes from your hardware manufacturer. And this is extremely rare. It is possible that in some cases you get BIOS updates regularly, as someone has just said, Dhaira has said, but usually it's a very rare thing.
Sir, BIOS updates also happen if there is a change in architecture of the processor, but they want to make it compatible with last generation motherboards.
See, this is something that you have to understand. The processor architecture doesn't change. That is a part of the hardware itself. It is possible
No,
that,
no, sir. Like a new processor comes in the market which has a new architecture. So to
yeah.
make it compatible with the motherboard which was for the previous generation,
Mm-hmm.
there is a BIOS update for that.
Oh, so but then so basically, what then in that case, what happens is, see, it's like this. Generally, you do not buy your motherboard from a different company than your. I don't know even if it is possible or not. But the idea is, if you BIOS updates are, then in that case, it is not really an update. So when you'll buy a new PC which has that particular new processor, the BIOS that you will get will be the newer version, right? So the people who are already running the older version, they need not update it, right? Because that they don't need that kind of.
Yes, yes.
Right? Uh, so okay, guys, I think what is the strength now? 82. I guess we can start now. So Pranav is one of our shepherds already, and again, I like ask again: are there any volunteers to be a shepherd? Or otherwise, I start picking randomly. No? Okay. So looks like things are now falling behind. People.
Sir, I can try again. I did it on the first day.
No, I want other people to, right? Frankly, I know that there are at least 10 people there which who will probably like to shepherd every day, and this is very good. But I want others to come up, right? If there
Okay,
is no
sir.
one, I'll pick you. Okay, but let me
Okay,
search.
sir.
So Ayushman Bajpayee, yeah, just unmute, and I think Vatsal, you were also done it, right? But you were a shepherd yesterday, right? Uh, uh, Yeah, I just someone's speaking. It's the volume is very low. Yeah, Ayushman, your volume is a bit low. Can you like see what is the issue? Okay, Arunim, you would like to be a shepherd?
Sir, now it is clear.
Yeah, now it is really clear.
Am I
Arunim,
audible, sir?
yeah, you're audible.
Okay,
So,
sir.
so we have three, right? Pranav, Ayushman, Arunim. Any more? I'll pick at least one at random, but I can accommodate one more volunteer. Okay, Saniya. Saniya is another one. Um, Saniya, and then I'll need one more. I'll just pick one. Uh, Jay Mehta. Okay, sorry. This is B.Tech CS1, right? Huh, right. That is right. Jay, are you there?
Yes, sir.
Okay, so Jay is there. So now we have five. Pranav, Ayushman, Arunim, Saniya, Jay. We have five. Okay, so let us start. Let me share my document. And by the way, one clarification: whatever whatever lectures, yeah, it is open, Omkar. you can actually mark your attendance. Uh, yeah, the one clarification, whatever lectures I will have to give you, 99% of the times they will be there by Sunday. Okay, so I'll give you at least a couple of days to watch them. I'll try to actually give them even earlier, but right now I am also busy with the grading your seniors, so that is taking up a lot of my time and effort. But once I'm done with their grading, you should expect that you'll get your videos by Thursday or Friday itself. um, and then whatever videos I give, okay, 1 2 3 4, whatever videos I give, once we start with the shepherding, there will be no new videos. Okay, so we will use these 3 lectures to simply discuss those those lectures. We will discuss doubts from those lectures. And one more thing, if you have not been able to set up a virtual machine till now, it's fine, right? That was more of an exercise that I wanted you guys to do. Even if you have failed, you would have actually still learned something, right? So please don't worry much about virtual machines as of now. From the next week onwards, all you will require is some place where you can type bash commands and run GCC. If you have access to any such place, it could be it could be on WSL, it could be on your MacBook's terminal, it could be on a virtual machine, it could be on a VPS or something else. All I would expect from you is that you have access to bash, right? Other than that, I have no expectations. So if you have not been able to somehow set up a virtual machine, it's completely fine. Yeah, somewhere, anywhere. The idea is that you should have an access to bash somewhere.
Sir, sir, how will these bash commands help us in coding and all?
So first of all, when you start coding, it's like this. What kind of IDE do you guys use? Have you used an IDE before, Nishchal?
No, sir.
Okay, so it's like this. What happens is the program itself, you write it in some kind of a text editor. Uh, there is some looking at the guest editions. Um, Nehal, I'll probably there was a video by someone, right, who had created a video for installation of guest edition. Have you guys watched it? Was it helpful? Or otherwise, what I'll do is I'll probably record another video for guest editions itself. It's a very simple thing to install. It's just that if you are new to the Linux world, you may not know how to do it. So what I'll do is I'll show you the different ways in which you can simply install guest editions.
Sir, I
Hello.
actually have Ubuntu server and I ran it on the terminal and I checked also that they have been installed, but still it's not like having any effect.
Yeah.
That option for having automatic resize is grayed out in the menu.
Yeah.
So, sir, it
Yeah.
is there, but it's not working.
So what happens, Nehal, is that the guest editions is only helpful if you're running a desktop version. If you are running a server version, the guest editions is not really helpful. So if you want to increase your screen size in the server edition, what I will do is I'll show you how to do it. Okay, you can increase the size of your screen even in the server edition, but there is a different way to do that. um, I will probably point you to an article, and this is for everyone. If you are using a server edition, maybe the size of the window that appears on your screen is smaller. There is a second solution which is probably the best solution. Someone had asked me this query over email. I replied to that person. I'm not sure whether that person is from IT, CS, or CSAI. So that person had a query about headless mode of VirtualBox. That is actually a very good mode to run into, and I did not discuss it because I thought it will probably be too much of virtual boxing for you. But the idea is something like this: you can run your VM like a background process, and then there is an idea of connecting to your VM through SSH. So basically, it's a way of saying. I showed you in the video that you can create a virtual machine on AWS, and then you can connect from your terminal to that virtual machine. So the same concept is here, that you basically start your virtual machine, and then you use If you are on Mac, you already have a terminal. You can use that. If you are on Windows, there is a tool called Putty, Putty. You can use Putty to create terminal windows which are connected to your virtual machine. I did not talk about it because I thought it will be probably too much, but maybe I'll create some video about it, or someone can volunteer if you already know how to do it. Just run a VM in the headless mode, and attach a network adapter to it, which is either host only or internal network, and create a video for students, for your batchmates. If you can't do it, I will do it, don't worry. But there are ways in which you can access your guest operating system from your host operating system, and that resize problem will not be there. This is only for server editions. If you have desktop editions, simply install guest editions and you are done. For those who are using server edition, there is another way that I can tell you. Okay. Yeah, so we have five. Sorry, I keep on drifting. So we already have five.
Sir, my doubt.
Yeah, go ahead.
Sir, I asked them that how are these commands going to help us?
Oh, sorry, Nischal.
No, it's okay, sir.
Okay, so what will happen is, whenever you write code, your code is actually written in a very simple fashion. You can use uh, any code editor, any text editor to write your code. You can use Notepad, for example, to write your code. But beyond that, what happens is, there is a kind of environment where your code has to be compiled and it has to be executed. And sometimes there is something which is in between these two steps as well, right? So you have to create probably a shared object, and that shared object has to be built into an executable. So all these things, creating, compiling your programs, creating shared objects, building your programs, this is not really a part of your programming language. This is a part of, let us say, in some ways you can call it as it is a part of system management. I know you have a subject with the same name. I'm not sure what you are being taught there, but essentially you need to know the environment in which your program runs. And it is we have chosen Bash as the environment where our program runs. Why we have chosen Bash? I think we had discussions over it yesterday. What is the advantages of learning Linux? Why learn Linux? Why can't we simply I'm not sure whether it was in your session or in the session with IT guys, but we had a long discussion of why we should use Linux. Why can't we simply use Windows, for example? So I'm not sure it was with you guys or with them.
Sir, not with us, I guess.
Okay, so like let's just I mean, I'll give you probably a 1 minute more on this. So essentially, when you join some company after completing your B.Tech, there is a good chance that you may end up working on some server machine. So what do I mean by server machines? They are really nothing more advanced or something like that. It's just that they also run Linux or some other operating system like Windows, for example. But server machines are large machines. That is, I'm talking about machines which are having RAM of 64 GB or something like that, 12 cores, 14 cores, 20 cores, those type of machines, and they are used to perform a number of things. For example, this particular session in WebEx, there must be some server in Cisco's data center somewhere which is making this happen. Okay, so your server machines have a lot of load, and even though your laptop you can have any software tools that you want, on server machines things are very finely tuned. Okay, finely tuned as in, you need absolutely high performance configurations, right? You do not run anything on that server machine that is not absolutely required. So usually what people do is, number one, they use Linux operating systems to run their servers. Somebody has already told it in that, like, oh, okay, that was a different batch. So Linux, because it is free, Windows has a very high fees. Okay, if you want to buy Windows server, Windows does have a server edition, by the way, but the amount of money that Microsoft will charge you is significant. Sometimes it's even beyond the limit of smaller enterprises. So that's why Linux, because Linux is free, people use Linux. That is one. Number two, they use server editions where there is no desktop. Why? Because desktop, these GUI, whatever is whatever windows are created in your desktop, they take up a lot of resources, as in they eat up a lot of RAM. So for running the same set of applications, if you have a desktop environment, you'll need more RAM as compared to let us say just a terminal based edition of your operating system. So on most all the servers, there is really no desktop environment. So everything has to be done by you using some shell like bash. So when I say everything, it means the moment you land on that server, it will not just be just running your code. Okay, it will be, you'll have to go and edit configuration files. You need to know how to stop and start services. You need to know how to search for a file with a particular content using just your commands. Am I making sense? So basically there are so many things that you will do that is not really a part of, that is basically a part of system management, that you need to learn anyhow. No one is going to teach you these things. You have to learn it on your own. Okay, there will be no subject where you are taught bash, for example. Okay, you are supposed to learn it on your own. And this is why I thought maybe in the first week I'll just dip you in that ice cold water. Okay, so that you understand the real problems you will face. So all this, all this activity that we are doing till now, we haven't even started with programming. It is all just to prepare you. So does that answer your question, Nishchal?
Yes, sir.
Okay.
So may I ask something, sir?
Yeah, go ahead. Sahil, your mic is really troubling. You can type your question, Sahil. Uh, my laptop is getting slow. Himanshu, I'm also running an 8 GB RAM laptop, and so it's like this. You don't have to keep your VM on all the time. You can switch it off. Okay, the moment you switch it off, it doesn't matter, right? I mean, your laptop is back to the same old state. Your VM consumes resources. Maybe you have given it far too many resources. Don't give it more than 3 GB. And when you run that VM, I expect that you're not playing games or talking to friends, or okay, you're just working. Okay, and when you're not working, switch it off, and then you should not have a problem. uh, uh, okay,
Excuse me, sir.
let yeah, go ahead.
Sir, there's when we close VMR, then
Mhm.
there's the option of suspending it and powering it off.
Yeah.
So what's the better to like
Suspending
when
is
to use?
similar to hibernate. Suspending is similar to hibernate on Windows. If you suspend it, your machine, basically its state is saved, and if you switch it on again, it'll go back to that same state. Okay, so suspending is similar to. Have you guys used hibernate on Windows? That is exactly the same thing as suspending. Your VirtualBox simply saves the state of your VM, running VM. Okay. Um, if you have time, you should usually shut it down. That is a good thing to do, but there is no problem. Either of the two is an acceptable thing. Okay, you can either shut it down, or you can save the state. Both are fine.
Okay, sir.
Yes, Akshat, you can use bash online. I think Pranav has a solution for you, and Abhinay also has a solution. Abhinay, is are you a part of this group only?
Yes, sir.
Okay.
Yes.
Yeah. So these two guys at least have two solutions that you guys can use, and please contact them if you want to use their solutions. Someone in YouTube, and he said that the RAM locate will only be used by it when Ubuntu server is on. Yes, Sahil, this is right. This is right. Your RAM is only used when your VM is on. If your VM is off, it doesn't use any RAM. Okay, and uh, any other queries, guys? Already written the command. So this is the SSH command that you can also use. Who was it that asked? Nehal, right? You asked about server versions problem, right? So this is another way that you can do. You can basically do an SSH to your server installation. I will probably create another video and that will help you out. Okay, so any other queries, or shall we start with, we only have I think 2 or 3 questions today. So any queries that you have? So one more feedback. You guys now understand this shepherding model? How will it work? You are basically supposed to go through the lectures over the weekend, and then maybe note down your doubts. You can of course send me emails whenever you want, and during these sessions, this is what we will do. Okay, we will just try to find out ways in which we can understand the same concepts through discussions. So this is the whole shepherding model. So I hope this model is helpful. Um, Otherwise, I can also go back to the same model that pretty much everyone is using. I can simply record my lectures and I can give it to you. But if you feel this is a better option, we can stick with it, or we can simply go back to the normal mode of teaching where I either give you live lectures, or I give you lectures, and we just have question answer session in the lectures. So think about it. You don't have to come up with an answer here. Just think about, you have, I know that you guys have informal groups, so please talk in those informal groups, and uh, just tell me, if you would like to stick with this model, or do you want to go back to the regular teaching model. Okay, so let's just start. No, yeah. So this is why, I mean, Sahil. I mean, this is. I mean, I used up 2 weeks just to provide you some more background in computer science. This was not really a part of the course. Bash, I can probably include it in course evaluation, because as I said, it is a part of system management. But whatever I taught you in the first week, the week 0 part, that is certainly not a part of your curriculum. Okay, virtual box and virtual machines and kernel and hardware and all that stuff, that is not a part of your curriculum. I just wanted everyone to be at the same stage, that even if you did not understand everything, at least by now you should have a brief, you can talk in brief about what a computer is and how a computer works. Okay, and you should have a broad overview of how a particular program starts and how it operates. So this has been the learning for the first 2 weeks. And then from here onwards, we are going to actually start, from the next week onwards, we are going to start your actual work. It is known as introduction to programming. I have not taught you any programming till now, but I am going to teach it now. Okay, so guys, any more queries, or we'll start with the first question? Okay, so we'll start with this question. Have we discussed system calls yesterday? So sorry guys, I actually get confused, because there are 2 batches and we are usually at different questions. So
Question 4, 5, 7, 8 is left. 6th is done and first 3 is done.
okay, so 4, 5. So let's start with 4. Any of the shepherds can pick it up.
Yes, sir.
Okay, it's okay. Can
I speak? You heard.
Okay, basically the desktop is contains the application that is suited for the general use, mainly that is for the office use and the multimedia software storage, and for the web browsers and etc. But the desktop contains the packages that contains the email server, file server, and etc. And continue.
Server version basically provides only us with the command line interfaces, whereas desktop version provides us graphical user interfaces also.
Any queries related to if anyone has any doubts about server and desktop versions, you can ask now. So okay, I am assuming it is clear now. Yeah, anyone has a doubt, I thought.
Yes, sir.
Okay, go ahead.
Sir, what are the different examples of server and this desktop distribution?
Sir, can I?
Yeah, I'm muted. You can speak, right? I mean, I won't
Yeah.
intervene.
And the desktop basically contains, or the examples are that it stores it is a multimedia software. It enables us to use the web browsers, and and the server includes email server, file server, and the web browser which we are using. Its server, that is the web server.
No. So the server version is basically the command line version. So you only have, let us say, for example, you just have a bash, okay? And over
Yes.
bash, all the commands that I explained in the lecture, cat and cd and ls and sed and grep and find. So all those things, they are a part of your server version. A desktop version will probably, most probably have a shell plus something more. And what is that something more? You will have, for example, a word processor, uh, you will have a web browser, you will have a file explorer. So in what is okay, this is something I already know. What is the name of the process in Windows which allows you to browse files and everything on your computer? Does anyone know?
Explorer.
Yeah, very good. So there is a counterpart of Explorer on Linux systems. It depends on exactly your desktop environment, but basically there is a counterpart of Explorer. So all these things are part of your desktop version. So usually, I have not really known any desktop version that did not have uh, terminal with it. So you can probably say that a server version is basically kernel plus shell. Desktop version is kernel plus shell plus something more, and those something more depend on what desktop environment you are using. Is that clear?
Yes, sir.
Okay, any other queries?
Sir, that part was left, sir. I had asked a doubt about file systems in LVM.
You have I think the WebEx is still making issues. What was your doubt?
Sir, the LVM file system one towards the end of yesterday's lecture.
So file system, we will have a doubt. I mean, is it not there, right? I did not write that question.
Yeah.
Okay, let us just go through this. I will add this question at the end.
Okay, sir. LVM one.
So what was your doubt? I'll just write this question here.
Sir, I am not clear with the LVM part.
LVM.
Yes, sir.
Yeah, see, LVM might be a bit too advanced right now for us to understand. Emma, you can drop me an email. I will talk to you directly.
Okay, sir.
Yeah. So we are done with this question. Anyone has any queries about question 4?
Yes, sir. I have one doubt.
Go ahead.
In the desktop version, we have certain applications. So can we use all those applications in the server version also, like using
No.
the commands and all that?
No. See, this is what you can assume that server version is a subset of the desktop version. Okay, so usually everything that you can do with the server version, you can probably do with the desktop version. It's not technically correct. It's basically they are actually independent. Every Linux distribution has a different set of packages. Plus, you have the customizability. You can download, you can download Ubuntu server and make it Ubuntu desktop. You can download Ubuntu desktop and make it Ubuntu server. So there is so much of customizability out there. But in a generic way, we can say that server versions are subset of your desktop versions. So usually it is the other way around. Whatever you can do in the server version, you can probably do it in the desktop version. but the converse is not true. Does that answer your query?
Yes, sir.
Yeah. So, guys, any more questions, or we'll move to the next one? Okay. So, have we discussed this, or
No, sir.
so I think the other batch is already ahead of you guys. They are only having these 3 questions. Anyhow, so let's discuss this one.
So may I?
Yeah, go ahead.
So a system call is basically when we run an application. So the application doesn't have as direct access to the hardware. So application makes the system call to the kernel, and then it interprets the program like instructions. What we need to do.
Yeah, I'd like to add an example over here. Suppose we did not have system calls, we would and your program wants to write, let's say, a file to a disk. So what your program would do is open that disk, let's say hard drive, and try to write that file over there. But what if there's another program which is also trying to do the same thing? So you might end up overwriting or corrupting your disk. So kernel provides system calls, which are basically a way of your program asking the kernel to hey, can I use this disk, or can I write to this disk? So suppose you want to write, let's say, hello world to your hard drive. So you'll tell the kernel, you'll make a system call to the kernel and tell that I want to write hello world to this part and this particular hard drive, and then the kernel will make sure that no other program is trying to write or trying to corrupt the same part, and it will execute the system call. It also helps us with permission management. For example, if you don't have the permissions to overwrite a particular file, or if you don't have the permissions to delete something, then the kernel will give your program an error that no, you don't have the permissions for this. So those are system calls. You also have system calls. Some other examples of system calls are like writing, reading from memory, reading from hard drive, trying to connect to the internet, and so on.
So, any queries about system calls, please ask now.
Sir,
You don't have to address me. You can simply say
okay,
anything.
sir. Sir, so Pranav said that if we write hello world, then it goes to then kernel, then system calls, and then kernel basically where to allocate that hello world in hard drive. And is compilation a system call? I want to.
Not really. When you compile something, you're going through a bunch of steps. So for example, if you're compiling your program, first you are reading the source file, right? First of all, you'll let's say your program name is program.cpp. So you'll first read the program.cpp. So when your compiler, in this case G++ in GCC, when it tries to read the program.cpp, it first makes a system call to the kernel which asks for read permission. So if the kernel allows the compiler to read that program.cpp, then the compiler will read that program cpp. It will do whatever operations it has to do to make the a dot out. I think usually it's a dot out to make the output file. And then after all those operations are done, it may also have a bunch of system calls in between, like linking and stuff, but that's not a part of this discussion. So after all that is done, it will perform write call to the, it will make a write system call, and it will write the file called a dot out. Does it answer your question?
Yes, thank you.
Yeah.
So, any more queries on system calls? Okay, so I assume it is clear now. Let's move to this question then. Okay, have we discussed this already?
Yes, I think we have done
Yeah,
that.
yeah, yeah. Yeah, that I remember we discussed. So let's go
Yeah.
to this. Anyone can pick up. Any shepherd can pick up.
So here, shell is something which is built over the built over the kernel. It is a program that runs instruction, but terminal is something like a hardware that provides that takes the input or provides the output. For example, our monitor or the keyboard or the mouse. So these things are the terminal, and the shell is basic
Uh,
difference.
okay. Anyone else in the shepherds?
Yeah, hello
Yeah,
sir. I
I
want
could.
to add something here. So shell is a program which processes commands and returns output, but terminal is a program that run a shell actually.
Yeah. So
Okay.
so let me like give you a very simple way to explain this. Uh, Terminal is actually a part of your desktop environment. Okay, so terminal is a GUI application. It might be confusing, but the idea is terminal is a GUI application that gives you access to the shell. Okay, in a server version, when you boot up a server version, whatever you get, okay, you get the shell by default. Okay, this is what appears on your screen if you have only a server version. But if you have a desktop version, what appears on your screen is a desktop. Okay, you can go to start and start a program like web browser or a word processor. Similarly, similar to web browser and word processor, there is another GUI application called terminal. But what it actually does is it gives you access to the shell. Okay, so you can open one or more terminals on your desktop, which basically means you have one or more shells available to you to talk to kernel. Okay, so a terminal is another application. It is I can understand why Sanya was confused. Terminal is a word that is also sometimes used to refer to hardware, but here we are not this is not the term. We are not talking about terminal as in a hardware. It is terminal the application. So if you remember, if you are on Ubuntu systems, L Ubuntu or any Ubuntu, if you press Control Alt T, whatever will pop up, that is a terminal. It is a window. Okay, you can drag it, you can minimize it, you can maximize it. Everything that you can do with a typical GUI application, you can do everything. Okay, yes, no, Nehal. So basically, terminal is a place where you can access. So shell is another program, terminal is another program. What happens is terminal is capable of giving of spawning. The actual term is spawning, SPAWNING. Okay, spawning. So a terminal spawns one or more shells for you. And so this is what I was trying to tell you, that if you are in a typical desktop environment, for maybe a normal user, whatever interfacing you have to do with the kernel, you do it through GUI applications. You don't understand that some system calls are going on in the background. The GUI applications do it for you. You can do the same thing. uh, just type it on Google. Okay, just find out the dictionary meaning of the word spawn. It is the same thing here. So spawning means giving birth to someone, something like that. Okay, so basically your terminal can actually create one or more shell instances for you. So they are all processes in your system. So what happens is terminal is just a place where you can use a shell to interact with the kernel. You have to understand this. If you are using a desktop version, um, yes, Divya, that is what it is. So basically, as I said, in a typical desktop environment, you do not need the shell, right? Because whatever operations you are going to do, you are going to browse the internet. You are going to edit files or open files. Um, you don't really need the shell. You only need the shell if you do not have a GUI. But let us say you want to use the shell in order to interact to the kernel. Where do you type your commands, right? This is where terminal comes in. Terminal is another GUI application, but it basically shows you a shell within that window, and there you can go and type your commands. Is it a bit more clearer now? So in video games, yeah, fine. Can we access all kind of shell from? Yes, in theory, yes, Uttaran. So basically, once you what happens is, let us say your default shell is bash. It is possible that uh, Sahil, do you have a question? Okay, so so let us say you
Yes, sir.
opened your, yeah, just a minute. I'll answer
Yes, sir.
Uttaran, and right. So. So let us say I have opened the terminal. The default shell would be some shell. Usually it is bash. If you have other shells installed on your system, you can actually switch from one shell to another. Okay, it is possible to do that. Or you can go and set a particular shell as your default in the terminal settings. Okay, so you can do all those things, and so it is possible to have multiple shells installed on your system, and your terminal can show you any one of them. It is possible to do that. The other so other than bash, there are at least two more that are popular: z shell, zsh, and c shell, csh. So instead of bash, you can also use these, any of these shells. Okay, now I'll first
Sir,
answer Sahil.
sir, I was asking about that more.
About that.
Sir, from a single window from off terminal, we can access only one shell, or otherwise we have to change it from other settings and then get back to access other shell. Is that?
You no, you, so it's like this, right? So there is a command to change your shell also. Okay,
Okay.
similar to cat, similar to ls. um, if you have, for example, zsh installed on your system, if you type zsh on bash, your shell will change to zsh. Then if you I'm not sure what is the command for bash. It is probably sh. So if you
Okay, sir,
type,
I got the idea about that.
so Sahil, what was your question?
Sir, I had two questions. Firstly, I wanted to ask that when we open that cloud server which Abhinay and I think Pranav gave
Mm-hmm.
in PowerShell or any command prompt,
Mm-hmm.
so we know that these bash terminals communicate to the kernel
Mm-hmm.
and kernel communicates to the hardware. So the sir in Windows, sir, where is the kernel and where is the like
So
So
may I?
yeah, go ahead.
Okay, so when you connect to my server, you are basically you are basically giving up control of your system and you're connecting to my system. So this server, like particularly my server, is located in Germany. So there is actually a computer in Germany, and you're connecting to that computer. And whenever you make a system call, a kernel call, you're making a kernel call on that computer. So
okay.
suppose you type cat, or let's say you type ls, which is shows the directory, which shows the files in the current directory. So if you type ls, then that ls call will happen in that particular computer's kernel.
Okay, so we will if we try any commands in bash, we will get the outputs in that particular computer.
Yeah, so for example, if you ask the kernel to write a hello world file, then that hello world file will be written in the computer in Germany, not on your computer.
It is like
Okay.
remote access.
Yeah, it is like remote access.
It's more
Okay,
like
got it.
we all have used TeamViewer, so you are just viewing our systems, but not as TeamViewer. You are just logging into it from a different computer, your system.
Got it, got it.
So anyone has any more doubts?
Yes, sir, I have a doubt.
Yeah,
Why
go
do
ahead.
we need different shells?
Pardon?
Sir, why do we need different shells?
uh okay, let me first get a clarification. Are you trying to ask different shells as in bash, zsh, csh?
Yes,
or
sir.
you're
Yeah.
okay, this is what you want. So they are just like different styles. The set of commands that you can give on ZSH are different than the commands that you can give on bash. Plus uh, there is a way of writing scripts. I have not yet talked to you guys about scripts, because I thought it might be a bit too difficult to it is probably not right to ask you to program without actually teaching you that. So so we are going to study C programming in this subject, but you can also do something as bash programming. Okay, so you can write programs simply in bash as well. So the syntax of those programs, okay, that is defined by your shell. So bash has one particular type of syntax. That syntax is very similar, I think, to Python. Okay, then you have a C shell. C shell is the syntax of that shell is very similar to the syntax of C. So this is why you have different shells. Okay, they are basically say it is the same as saying, why do we have both Java and Python? Why don't we just do away with one? It's there because people want to have different styles of programming. So similarly, people want to have different types of shells, so that we have more than one shells available.
Okay.
Okay. Any queries, guys? More queries?
Yes, sir. So while we installing certain compilers or anything using terminals, so does it have a list of these programs or software which we can install, or how does it
Oh,
work?
yeah. Okay. So it's like this. So there is something known as a package manager. Every Linux distribution comes up with a package manager. Okay, that package manager is aware of what packages are available for your distribution. It doesn't come pre-installed. I mean, all the packages that are possible in, let us say, Ubuntu world, they're not installed by default. I mean, we are talking about thousands of packages, maybe lakhs. But your package manager, in case of Ubuntu, it is apt, apt. Okay, apt is your package manager. That package manager knows what are the software that are available, and it maintains a list of these software at some particular location. Not the software themselves. It doesn't bring the software and install it, but it has a list of the available software, and then you can pick one from it and install.
Okay, thank you, sir.
Okay, there have been a lot of chats in the while. I hope I have not read all of them. If any one of you have any queries, just unmute and ask. And please ask your shepherds first. If they are not able to answer, then I will answer.
I just wanted a confirmation that the terminal is basically a GUI which provides us with a CLI, because inside it we type commands.
I mean, guys, is it clear to you, or it's like, I mean, again, robotic voice for me?
So she's asking about terminals. So can I give a little bit of history so that they get a background about terminals?
Yeah, go ahead.
Okay, so basically terminals back in the day, like I mean 1970s, 1980s, terminals were actual physical devices. You can look up VT100, Video Terminal 100 on Wikipedia. So those were the terminals. They were actually like computers with a keyboard and screen, no mouse, obviously. So, and then after that, around 2000s, people got rid of terminals because they got better computers like with mouse and stuff like that. So now they still wanted to access shells. So how do you access shells? So you emulate the terminals. So around 2000s there was this application called Xterm. So that basically behaved as if it was a terminal and talked to the shell. So right now shell does not have any idea that you are actually using a newer computer. It just thinks that you are using an older terminal like VT100. That's the particular model that Xterm emulates. And today, like in 2020, what we have is emulators that emulate Xterm. Like this gets a bit confusing, but whenever you are using, let's say, your Control Shift T in, oh god, it's robotic and one thing. So whenever you're doing Control Shift T today, you're actually using an emulator that emulates VT100 indirectly. So basically, shell does not the shell, let's say bash or CSH, does not have any idea that you are using a new computer.
It's just
still
receiving
that you're
instructions
using,
without knowing where it's receiving them from.
yeah, it still thinks that it is using VT100 or VT102. I think it was for like now, like X terminal is VT102. Yeah, you can look it up on Wikipedia. But basically, today's terminals, quote unquote terminals, are actually terminal emulators, and they emulate a terminal called VT, a terminal which is a physical device called VT100.
Okay, thank you.
I hope that clears it up. Guys, any more questions?
Pranav, can you please explain fifth question again?
Fifth question, system call.
Yes, sir. Yes.
Sir, क्या रे
Sorry,
मतलब?
sorry, sir, नहीं
Okay,
बोला.
I'll try to explain fifth question again. Should I do it in Hindi? Would it be more
Yeah, you
helpful?
can. Yeah.
No, like, would it be more helpful for you if I do it in Hindi?
Both. You can use both languages.
Okay, I'll do it English again then. Okay, so let's say you own a pen drive. Okay, so you connect that pen drive to your computer, and you have a program which writes a file. Let's say a photo of you. Okay, a program that transfers a photo of you into that pen drive. You also have a program which transfers photo of your dog, let's say, which transfers the photo of your dog in that pen drive. So what might happen is your program as well as your dog's program try to access the pen drive at the same time, and what might happen is you end up corrupting the pen drive because you're not accessing it in the correct way. So to prevent this from happening, the kernel acts like a middleman, basically like a supervisor in this case, to your programs. So what your program does is it makes a system call, which is basically a message to the kernel saying that, hey, can I write this particular file to this particular pen drive? So the kernel might say, okay, you can write this file to the pen drive on this particular location. Whereas your dog's program also does the same thing. Now the kernel knows which position is already written by your program. So what the kernel does is it gives a different position for your dog's program, right? So in this way, the kernel manages and makes sure that there is no corruption and stuff like that. It is actually a bit, it's not a bit, it's way more complicated. It also manages permissions and stuff like that. But for now, you can just say that the kernel, the system calls are basically requests to the kernel to provide a specific resource to you. In this case, it is the pen drive.
So system call is made by.
I'm sorry, your voice is getting cut, but is your question, are system calls made by programs?
Yes.
Okay.
Yes,
So yeah, so whenever you write a program, you will soon start writing programs. So whenever you write a program, you actually make the program make system calls. So yes, your program will make system calls. Same for bash. Bash also makes system calls, or shell, or whatever.
Guys, I think Indra ma'am is calling me, and it's her class. Please, you can all move there. We can. I'm sorry. We can take up these things later. Maybe on email. Thank you.
Okay, sir. Thank you, sir.
Bye, guys. Bye. Bye.
Thank you, sir. Thank you, sir.
Thank you.